All right, so this is Securing Web Applications, this class here. And I just want to tell you the overview and do the first chapter or two tonight. So we're going to use this book. This book is written by the author of BURP, and most of your projects are going to be the Web Security Academy. This is excellent. BURP is the product used to test websites for vulnerabilities, and it is the product used by people who search for bug bounties, although I would not expect any of you to make money from bug bounties based on what you'll learn in this course, because you have to be the first to find the most important bug, and I've never been able to do that more than once or twice. But you can be quite valuable for doing security audits and finding security problems and fixing them, even without being the number one to win the bug bounty. Yes, I think that's quite true, Julie. That means, I was saying before, it means New Zealand and Chinese people, I think, can pretty much live their life without worrying about COVID. I think you're right, because they really do stamp it down. Anyway, so there's the book. There's going to be most of the hands-on projects. We have a few to do before that. And so we'll talk about how the web works. The main thing students have to learn here, which is a little difficult for them, is understanding how complicated the web is. When you open a website like Amazon, you are not talking to one server. You are talking to a whole bunch of server and database products that are all working together to compose that web page using many languages and many transmissions, and the security flaws come from the mistakes made in interpretation as one of those devices talks to another. And we're going to be going into that in quite a bit of detail. So there's a textbook, there's quizzes online in the Canvas system. If you're not a City College student, you can take this course. You won't get official college credit, but you'll be the same as any other student. But you go to a different Canvas for quizzes here, because for the privacy of the students, I don't want to mix non-CCSF students with the CCSF students. And there's also discussions, which go into your grade. And so here's the schedule. We'll do the first chapter tonight, and I think we might be able to do the second chapter too. And then things start getting due. Nothing is really due until 216, though, because people might still be adding. Yeah, the Burp Suite Qualified Practitioner cert is what you could get to. Now, I went through this, and I was not even ready to pass that test yet. So if you do enough to get an A in my class, that's probably not enough to pass that exam. That exam would require you to go through all of this Burp stuff probably twice or three times until you get really good at it. But yeah, this does in fact lead to towards that certificate. It's the official training material for it. So absolutely, there's a certificate. Okay. And so these asterisks mean I recommend doing these projects by that date, but it means they're not really late until you go down here, because some people might still be adding, and there's no point having them already late. All right. And so let me just bring up the grading policy. Yes, okay. So there's quizzes, there's projects. Oh, there's also discussions that aren't on here, so I think this total is not right. But anyway, there's total number of points, 90%'s an A, 80%'s a B, and so on. And I will have a announcement inside the Canvas shell that tells you exactly how many points you need for an A and a B and a C. So you should not be surprised by your grade, and you can make sure to get enough points to get whatever grade you want. Because the main thing we do is homework projects. And if you look here, there's some projects to get you started here, and you'll notice there's required points, and then there's extra credit. Like here's 155 extra credit points on this one, and the Web Security Academy is huge. And I only required like 2 of these a week, but you could do more, and they're all worth extra credit. So you can just get extra credit by doing extra projects, and that will compensate for discussions or quizzes or anything else, because the main thing about this class is the hands-on projects. You can use them. In fact, most of my students don't take the final exam because they do enough extra credit that they don't need to. They already have an A without taking the final exam. So, all right. And so you'll do projects and find flags and submit them in Canvas to get your points. All right. So let's take a look at the first chapter. And by the way, if anybody is here to add, I'll check that after I go through a chapter here, although I think this class is not full. Is having passed the BSCP exam? Well, that's an interesting question. I don't know what a BSCP is. Let's see. Board of Certified Safety Professionals. This sounds like physical safety, huh? Not logical safety? Oh, Burp Suite certified practitioner. Oh, well, gee, I would think so, yes. Have you already done that? Yeah, if you've done that, I tell you, normally in my classes, if it points to a certificate, if you already have the certificate, you get an A. I mean, if you pass this test, then yeah, send me proof of that. I think that's worth an A. That's beyond my class. Absolutely. In fact, you might find this boring. Everybody's welcome, but if you've already passed that test, I don't think I have much more to tell you. You were in the top 100 to pass. That's awesome. Well, good for you. Well, feel free to chime in if you have contributions. You probably understand a lot of this stuff better than me then, because I have not passed that thing yet. Well, very good. Yeah, when I have classes that point to a certificate, that's generally my rule. If you get the cert, you get an A. Very good. All right. Yeah, well, you did the studying, and I haven't done the studying. I looked at the practice test, and I wasn't ready for it, and then I got distracted by other jobs. So, Anyway, please chime in. Any of you, applies to everybody. If you have a contribution to make, like if I'm getting something wrong, don't be shy. I won't get offended. I just want the material to be as accurate as possible. So let's talk about web application insecurity. Now, in the early days of the web, you would just have a server, and the server would have some files on it, like HTML files and JPEG. And when you viewed it, you would just view that static file. And that's how my web page still is. My web page is very old and primitive. But now, you don't have web pages like that. You have things like Twitter and Facebook and Amazon where you log in, and it knows who you are, and then it has customized content that you see that's different than what other people see. So you're not looking at a static page. And so, on top of that, you now have content that users put up there, like Twitter and Facebook. So now users can supply input, and that input might be misunderstood by the servers and have unexpected consequences. And that's the fundamental security problem of the web. So like I say, the static website just sits here, and there wasn't much to go wrong. You could have directory traversal sometimes by changing the URL and other flaws like that. But most of the time, there wasn't too much to go wrong with old Web 1.0. But the modern web app, you log in, it's dynamic content which is fetched from multiple sources, and a lot of people are constantly updating and developing the applications that are producing that content, and they make mistakes and create security problems. And you got shopping, banking, gambling, email, all sorts of things, and all these things are now Web 2, where the users are logging in and changing content, and each seeing different things. So then you got all the cloud services. Gmail and Google Apps and all the other things, administrative interfaces to servers, Kubernetes clusters and everything else. There's just a ton of services in the cloud, which again are taking requests from users and attempting to make sure that those users are authorized and then letting them do things, and various things can go wrong. So HTTP is designed to be very fast and efficient to run. It has simple requests. It's connectionless. Each request is handled separately. The next request does not have to remember the previous one. So it's designed to be very resilient, very easy to run on both ends. But this leads to consequences. As we're going to see, it is often possible to make a web server forget who you are or misunderstand who you are, and then give you permissions you're not supposed to have, because it doesn't have a built-in automatic, efficient way of keeping track who you are. So you get a lot of breaches. People can perform denial of service attacks to bring a website down, or they can take over the server or trick the server into handing out data they're not supposed to see, like seeing somebody else's email. So one thing people put now and then is they say this website is secure because it's secured with SSL. And SSL does mean the server has encryption and authentication, which means that you know which server you're talking to, and the data is encrypted, so third-party people sniffing on it will not be able to read it. But it doesn't mean it's secure in the sense that you can trust it, because there's a ton of attacks that will still go through HTTPS. And one of the many companies, there was a big interest a few years ago in blockchain technology to make secure voting. And people would claim to be 100% secure, and of course they aren't. And blockchains, as we were talking about in the news, are not 100% secure either. Nothing's ever 100% secure. So your text authors showed various vulnerabilities. The most popular vulnerability is cross-site scripting. It's so common. Many websites have it, which means you can put script on a website that will execute on the context of users who view the website. So it might endanger users one by one. It's sort of a way of bouncing an attack off the server and hurting another user, but it does not usually give you the ability to hack into the server and steal the company's data. So companies do not consider it a high priority to fix it, and a bunch of people just leave it there. Whereas things like SQL injection do allow you to steal the data from the server, and there's a lot of other problems. This one they'll take more seriously and actually fix. AKA XSS. Yeah, this is XSS, cross-site scripting. Yes, you can use cross-site scripting to steal the administrator's session token, and then you get in. That's right. So here's another one. This happens now and again, where there's a reflect. Yeah, good. These are very good comments. You can send a request to the server, and it will give you privileged information without you proving that you're the administrator first. This happens fairly often. One of the more common flaws is insecure direct object access, where there's a page like admin.php, and that page forgets to check who you are. They just assume that you would never get to that page unless you had proven you were the administrator, but you can go directly to it and then perform administrative activities without having proof that you have previously logged in as the administrator. So you can send a request to this server without authentication, and then it gives you information about the users, like their email address and name and such. And mobile apps are very much like web apps. Your mobile apps on your iPhone and Android are basically sending requests to a server and viewing pages in the same manner, and they have a series of famous vulnerabilities, and I did a project testing a lot of these apps, and they're pretty bad. I tested the major bank apps and insurance companies and stockbrokers, and many of them had serious vulnerabilities. They tend to be pretty badly written. They tend to have really bad cryptography. About half of them encrypt your password and store it on the phone for no good reason, and they encrypt it with the wrong kind of encryption, so it's easy to decrypt. And I've been telling people about that for years, and nobody cares. There's never any reason to store the password that way. But anyway, the current standard of the industry is just to do something stupid. This is the way things tend to go. Like 20 years ago, everybody put a default hard-coded administrative password for tech support on everything. And they thought that would be fine until people started finding them, and most companies have figured out to knock that off. But Cisco got caught doing that like 8 times over the last 2 years. Just, people develop a custom, and it takes a long time to educate them to knock it off. And then I found a lot of SQL injections at websites and other vulnerabilities, and a lot of websites infected with Viagra sellers and such. Just a lot of people get infected. And if you do this white hatting where you warn people about vulnerabilities when they have not hired you to do a test, then you generally just get abuse and you don't do much good. It's something amateurs did, and I've done it a bit, but there's not a lot of reward in it. Yes, I did. Yeah, I can't. Corinne, I can't identify my clients, but yes, I am working with a bank, and the top banks are now very impressive. I think the top banks have woken up to web security, and they really are doing a good job. So it is improving. That's why I started doing the top 10 banks when I did this. I said, well, obviously those people will be secure because they have a huge incentive, and I was shocked that they weren't. But they're improving. Yeah, and I am doing consulting for big corporations now, and quite a few of them are even quite serious about security. Anyway, so here's the fundamental problem. Users can send up data. They can send up a web request with parameters like username and password, cookies, headers, and the developers often do not really understand where their code is running. Some of their code is running on your browser under your control, and some of their code is running on the server. And a lot of developers don't really understand that. So when they put JavaScript on a page saying this input field will only contain letters and only be 10 characters long, they believe that's going to happen. But that won't happen if the user is using a proxy, or if they turn off JavaScript in their browser. They can defeat that. So you cannot assume that controls enforced on the client side have worked correctly. And that's what we're going to do. We're going to use Burp, the main tool you use for this, which lets you easily create malicious input to test for vulnerabilities on servers. So you can, for example, sometimes when you make a request to the server, the price of the item comes from the client, not the server, and so you can change it and get an item for cheaper. You can modify a session token to mimic somebody else's token and get in their account. You can remove parameters to change your how you're processed on the server. And then there's SQL injection, where you send a request which is misunderstood as a command and affects a database. Glow, we don't have access to the paid version, but I think you get a free 90-day trial of the paid version if you want to use it. I always just use the free one. But you can get a 90-day trial of the pay one and use that if you like. Good. Anyway, the point of this is all these attacks work right through SSL. They do not depend on breaking encryption. They just depend on sending a signal to the server, which contains unexpected characters, and that signal will just be encrypted and sent to the server right through the SSL. So when people say SSL makes me secure, it's not that simple. SSL stops some attacks, but there's a bunch of attacks it does not stop. All right, so the fundamental problem is that you've got everybody racing to put up new features and beat the competition, and your developers are working, and some of them are just making mistakes, being sloppy, not educated about security, and so that's the thing. People are rushing stuff out. The same problem with the Internet of Things. You're trying to get your product out fast and cheap, and you don't really spend as much time as you ought to securing it. Even if there are second factors, the security of stored tokens is still an issue. Yeah, the random students got there, the classic SQL injection. Yeah. All right. So, in the old days, like I said, you would have an edge server or a so-called bastion host or a firewall, something on the edge of your network, and you would say that's stopping all the attacks and everything inside the network is now safe. But now, that's not that clear. Now you can send transactions into the web app, and then it sends signals to other apps, and it's not that simple. The traffic bounces around among many servers, and it could be malicious at any stage. So you can attack the users with things like cross-site scripting, and if you do manage to, another problem is people forget their passwords all the time. So you have to have some kind of password recovery system, and those tend to be really weak. Like I think it was Sarah Palin got hacked because Sarah Palin was transacting government business with a Yahoo account, which is not a good practice. And Yahoo had a password recovery feature that had a proofing question, and the question was, in what town did you meet your husband? And somebody was able to easily figure out where that was. It's just the town where her high school was. So they were able to guess the answer to that question and reset her password and get in her Yahoo account. And that's the kind of thing that happens. The password recovery system is often the weak spot because you don't want to pay tech support to get people to actually send in a photograph of their driver's license or something. So you have some lame, weak system that asks some security question like that, and it's not that hard to guess. And that's one of the other reasons why, if you're working for a government or a company, you should perform all business with your official company account, because then that account can be secured up to your company's security policy. The free online Yahoo and Gmail stuff, of course, is at the bottom level of security because it's free and it's not considered something you should be using for business. That said, I'm using Gmail to get student homework coming in, but that's a fairly low risk, I think. Well, the securest form of two-factor authentication, well, there's argument about that. Now, the SMS form of 2FA, where they send you an SMS message, is the weakest because SMS messages are pretty easy to intercept. More secure is like these RSA tokens where you have a piece of hardware that puts out a number, or you have the Google Authenticator app on your phone where it calculates it locally. That's better. Another way is biometrics like face or thumb recognition. That's considered pretty good too. And there are other exotic ones like voice print and handprints. But the most common ones you'll see are SMS-based 2FA and app-based 2FA. And of those two, the app is much safer. YubiKeys. Yeah, YubiKeys is another one, yeah. And for Yahoo Mail, the second factor is the cell phone number and the cell phone SIM. That's right. And cell phone lost. Or you can do SIM jacking, where you just social engineer the tech support at the phone company to move their data to your phone. there's a bunch of attacks that work. SIM swapping, they call it. That's why, people really complain about SMS-based two-factor authentication. It's probably better than one-factor authentication, but it's the weakest form of two-factor. These are very good questions. All right, anyway, so I updated this today. I looked at a number of vulnerabilities in content management systems, and you can see they're getting better. Back here you had 40 or 50 vulnerabilities. Now you're down to like 8 or 4. Used to be code execution and SQL injection, but those are rare these days. So, the 10 years ago, 15 years ago, web pages and web apps were really, really bad. Now they're gradually getting better. So as time passes, the vulnerabilities get rarer and a little harder to exploit, but there's still plenty of them. All right, so let's do a Kahoot, and then I'll take a break. We'll see where we're at. I think we probably have time to do another chapter here. Okay. I should be getting down to it. 129S, Chapter 1. There we go. And let me just take a look and make sure that's good and that's good. Okay, we're good. So these are worth extra credit if you get the most of them right. There's the music. Okay. So go to Kahoot.it and type in that number. And if you're one of the top 3 performers, you get 3 extra points of credit. Oh, I see in the chat comment, which is right, you could use a cell phone interceptor, like a Stingray, to catch SMSs. There are easier ways, but that is one way to do it. And supposedly, you can protect yourself from that now with the latest version of Android by turning off 2G. Well, in principle, anybody could, but it's a pretty serious crime if you're not the cops to put up a fake cell phone station. It can be done, but it's highly illegal. There are pretty serious wiretap laws. Don't mess with the phone network. All right, looks like we got who's coming. All right, so what makes Web 2 different? Yep, that's it. Users are submitting content, which you then replay to other users, which is pretty extreme. I don't think Web3 is all a scam, but a lot of it's a scam. Anyway, all right, so what does SSL stop? the way you do it is you go to kahoot.it, and there was a number you had to put in. Yeah, someone's got it there. And the code is down here at the bottom. Go to kahoot.it and put in that number. And then you can try to guess, but you have to get the answer quickly to get the most points. It grades you on accuracy and on speed. But there'll be a lot of these. If you miss this one, I'll have a couple of these at every lecture from now on. So this is the point. It doesn't stop any of these attacks, but it does stop you from modifying data by placing yourself in the middle, because you can read the data and you can in principle alter it, but your alterations will not fool anybody because you don't have the encryption key. So you can just ruin the data so the server can't understand it, but you couldn't change it in any controlled way. Unless you defeat SSL or TLS, which is not completely impossible, but it's very difficult. All right, what's the most common vulnerability? Cross-site scripting, for decades, it's been the most common vulnerability. There's a bunch of people that find them and post them, and they're all over the place. Some very large number of servers of websites have cross-site scripting vulnerabilities. All right, what's the most important defense method? Yeah, most amateurs trust antivirus. Antivirus is pretty much done its day. The most important thing is updates. The worst thing you can do is have an old version of something, because vulnerabilities are found, they put out a patch, and if you don't put on the patch, everybody jumps on the attack. So most professionals say the most important thing is to keep your stuff updated, which is why, of course, you'll all find that everybody keeps bugging you to put on the updates, because it really is important for security. All right. Let's see who won. All right, I know who that is. And I know who that is from last semester. All right, good. All names I can find. Let me just put this here. All right, so let me stop this recording.